Hi, everyone. I'm Tom Vaughan. I'm the VP and GM of video for Multicoreware. We are the developers of x265, and tell you a little bit about that today. Is this not hooked up? One more dongle, Alex. We're blinking. All right, I'll just click on this. There we go. All right, so let me introduce our company and who we are. We were founded in 2009. We have about 150 engineers worldwide in 7 locations. We have 4 business units. I run the video business unit. Oops. So as Dan was telling you, HEVC adoption is accelerating. If you are responsible for the quality of experience that your video customers get, this is important. Netflix, Amazon, Hulu, many companies have been taking advantage of HEVC, delivering extremely high quality, ultra high definition experiences to their customers in the latest generation TVs, set-tops, connected set-tops. It was ratified 4.5 years ago. As many of you know, it's been a little bit held up by some of the patent license negotiations. It's been kind of the main issue. That seems to be getting worked out. At the end of the day, it's kind of the big device OEMs who will have to figure out how to get those patents licensed, and a lot of them have their own portfolios and plenty of lawyers, and they can kind of figure that out. We'll leave that discussion aside, but they are figuring it out. And as Dan pointed out, most new TVs have built-in HEVC decoders because most new TVs are smart TVs, and if you buy a 4K TV, you expect to see some 4K content. And if those cable and satellite broadcasters aren't giving it to you, well, then you just pull up the Netflix app or the Amazon app and you find some UHD content there. The devices are coming along, the chipsets are there. Most smartphones have had chipsets in them that support hardware HEVC encoding and decoding for quite some time, starting with like the Qualcomm Snapdragon 805, or even 801, I think, had some HEVC at lower resolution. But you know, all the smartphone SoC companies, MediaTek and Samsung Exynos, all of those devices have had HEVC built-in hardware for a long time. Those connected set-top box are all going 4K HEVC. It's a must-have in the connected home in the living room, in addition to the TVs. And the big news is that June 5th this year, Apple at their Worldwide Developer Conference announced that they are going all in on HEVC. And this is kind of a big deal to us. They're saying HEVC, is the new standard for video, and up to 40% better compression. It's really up to more than 40%, as Dan just pointed out. And what's going to happen is this fall, and they're a little non-specific about exactly that date, but this fall, roughly 1 billion devices are going to get an update that's going to light up platform-native HEVC. So Apple didn't just say, my new phone at some point in the future is going to have HEVC. They said the whole platform has HEVC. iOS, macOS, tvOS, HLS, their streaming protocol, and Safari. So Apple users, starting with the iPhone 6, will have kind of the platform-native encoder and decoder. They'll be walking around shooting video in HEVC, saving it, sharing it. Not only video, photos. HEVC can be used to compress photos, still images, with intra-only compression, 2.4 times more efficiently than JPEG. JPEG is a great standard. It's been around for a little while, 25 years or something like that. It's kind of old, long in the tooth, and it can easily be crushed in compression efficiency by HEVC. So that's going to take your 128 gigabyte iPhone, and it's going to make it the equivalent of a 200 gigabyte iPhone, right? What's the benefit in, what would that flash memory, that additional flash memory have cost, right? A lot more than it costs to license those patents and turn that technology on. This is very powerful technology. And it really hasn't been in the hands of consumers just yet, right? It's been in their TV, and if they were streaming movies from Netflix, Amazon, Hulu, et cetera, that was coming through HEVC, but we haven't seen it cross over yet to consumer compute devices and actually be in consumers' hands, and them being aware of it and sort of asking for it and looking for it in the new devices that they buy. So you see this list here. This is on Apple's website of all the devices that the updates apply to. It goes back all the way to the iPhone 5S. Right? Some of this will be in software encoding and decoding. But I know from the 6S onward, it's 10-bit, 4K, HEVC, fairly high bit rates. So these phones will be streaming content from various content providers in HEVC, 10-bit, high dynamic range. The smartphones are also going HDR with their lovely AMOLED displays, which the Android device OEMs have been doing for a while, and we kind of expect from the rumors that Apple will keep up. But we expect the Android world and the Windows world to keep up with the iPhone and Mac world. Why would they let Apple have video experiences that are twice as efficient, so meaningfully better experiences on those smartphones? They won't. And in fact, the hardware is in all the premium Android phones. It's been in there for years. And all they got to do is push out an update, and they can turn that on. LG has already advertised that their new G6 can stream Netflix and Amazon HDR movies and play it back in HDR on their AMOLED displays. Sony, the Xperia XZ, they're advertising the same thing. They actually have a 4K display in their smartphone. A little bit of overkill there. Samsung hasn't announced that HEVC support is in the Galaxy S8. We do expect them to turn it on in reaction to Apple. We kind of see them getting their HEVC patent licensing ducks in a row. They're part of both MPEG-LA's patent licensing group and HEVC Advances. A lot of these companies, by the way, hold patents, and so they're both licensors and licensees, so it's a little easier for them to work these things out than some of the others. But this is happening, and we expect that Apple's adoption of HEVC everywhere will be quite the catalyst for getting other device OEMs to move. So the real question then becomes, which content services, which applications, which services will take advantage of this, right? If I have a video chat app and I push that out as an iPhone app, and I have two users of my video chat app, maybe it's a WebEx or some Skype type of app. Why wouldn't I want to take advantage of the platform native capability? Apple's already paid the patent royalties, taken care of it. It's all in the hardware and it's in the operating system. Of course, my app, when it detects it's running on iPhones, and all the users can handle HEVC, you just want to take advantage of that, right? And if I'm a streaming video service and I detect that that client is HEVC capable, I'd be crazy to send them an AVC stream, right? I can give them a much higher quality of experience sending them HEVC. So that's the big question, guys, is what happens in the fall when 1 billion devices are all lit up with platform native HEVC? There's going to be a reaction. We think it's going to be a pretty significant one. So let's back up a little and talk about H.264. One of the leading H.264 implementations is an open source implementation called x264. I'm not a big fan of their logo, but this was a bunch of, with fire and everything. This is a very open sourcey project. Some engineers in a French university, Lorraine and Laurent, brilliant people, did this as a school project, and they were graduating, and they convinced the university to let them open source it. And in the early days of H.264, this was the leading H.264 implementation available to those open source people, FFmpeg, VLC, all those type of open source projects. And it attracted a lot of like-minded, brilliant developers, a very good following, Jason Garrett Glazer and lots of other talented people. And over time, it actually became quite good, and so good that many companies, instead of licensing a proprietary H.264 encoder, went with x264. And of course, the web-based companies, they have a strong bias towards open source libraries. They built their entire stack, their backend on web platforms on open source. So this is the native encoder in FFmpeg and VLC and Handbrake and all the open source projects. But it's the encoder that like everyone uses, not just web video companies, but commercial encoder vendors, the vendors that show up at NAB and IBC. We actually helped Multicore. The way we got into the video world was helping companies like Telestream figure out how to adopt x264 in place of what they were using before and make it run efficiently. And so we helped accelerate it and really optimize it for the platforms they were running on. Kind of got us into the world, got us working with them. And then in January 2013, when the HEVC standard was ratified, various people in the world were looking at each other saying, shouldn't there be an x265 project? There's this x264, we all use it. There needs to be an x265 project. And the developers of x264 mostly were these independent volunteer type of guys, and they looked at each other and they looked at the spec, which is quite a spec, and said, now it would take us years to do this. We really don't have the bandwidth to pull this off. But Multicore, if you guys want to do it, we'll support you. So I negotiated a special license from x264 LLC, the business unit, and that license allows us to port and adapt any and all code from x264 to create x265. So we build x265 very similar to x264 in terms of all the syntax, but we ported over all the good algorithms that we found in there, the look-ahead feature, the macro block tree. We have to call it CU tree because we don't have macro blocks in HEVC. All these different features, and of course they had to be adapted quite a bit because it's a very different animal, HEVC, than AVC. But we are standing on the shoulders of giants. We got some very good code as the basis to kick off x265. But we put a large commercial team behind this. We got funding from 4 different companies initially, kind of based on a slide deck that I had put together. Don't worry, you should buy this. We were at that time, I think, 80 times faster than the HM, so we could encode 1 frame of 1080p in 1 second instead of 80 seconds. So big progress. But of course, we needed to make a lot more progress. So x265, if you're not familiar, it's open source under the GPL v2. So if you use it in your own operation, in your own backend, in your cloud, on-prem, you can use it for free. You don't have to pay me a dime. And if you comply with the terms of the GPL v2, it's free. But a lot of commercial companies, they come to us. They'd rather have a business relationship with the actual developers, kind of direct our development, get support, all of that. Even though they technically are using it under the GPL v2 for free, they still want to find a way to make sure we're on speed dial and we're moving x265 in the direction they want it to go and adding the features and support and platform-specific support that they need. So here's an eye chart for you. Here are all there'll be a test later. Here are some of the features of x265. The point being, it's a very complete implementation of an HEVC encoder. This is software, not hardware, but we've supported pretty much all of the spec, and then there are many features you would find in x265 that you wouldn't find in the HM reference model, different rate control modes and psychovisual optimizations and various encoder tricks and things. But I think you'll find it, if you run it in your lab, to be fairly robust and fairly complete. And if it's not, please contact me. And just, it's not really a fair thing to evaluate video by looking at still images, but in case you haven't gotten the point already, this would be x264 of that famous video, Tears of Steel, at 400 kbps, 1080p. If I double the bit rate, the picture improves substantially. This is fairly representative. But if I just use x265 at 400 kbps, it's even better. And so really you should try it with your video, with different settings, but when you see how efficient it is, it's pretty mind-blowing. You can get 1080p, it's kind of typical content, down below 1 megabit per second, and it looks fantastic for typical content, below 1 Mbps, right? 4K, a lot of people are using 12, 15 megabits per second. Some people, if they want to go crazy and have great looking content, will use 20 or 25 megabits per second. But for most typical content, you don't necessarily need to even hit bit rates that are that high, right? This is extremely efficient. It has all those tools that Dan was discussing, particularly the ability to, all that prediction, intra and inter prediction is all much more accurate, right? And we then have all these tools like different block sizes and shapes to really fit all the prediction to the content much more accurately. It is a very powerful thing. So even 4K content, you could oftentimes have a great experience at 5, 6, 7 megabits per second if it's kind of typical dramatic content. Now, if we're talking sports, a lot of action, a lot of detail, a lot of motion, you're certainly going to want some higher bit rates. So what's the fundamental challenge here? HEVC is very powerful. It's got amazing benefits, but you don't get those benefits for free. You pay for them. And you pay for them in terms of computational cost, right? It takes 5 or more times the compute to go get those benefits. So everyone wants those benefits, but let's say I have an operation and I'm encoding a bunch of video every year, and I say, well, I need 5 times the compute because I want to convert everything over to HEVC. I want to encode everything in HEVC. I may still also have to encode everything in AVC, so I still have that 1x the budget for my encoding, and now I need to add to that another 5x the budget for all the computers I need to keep up and also encode everything in HEVC. So you go to the boss and you say, hey, listen, I need to get 6 times the budget for compute that I used to have, and the boss looks at you a little funny. So that's the struggle. How do we do this efficiently? And everyone comes to me and says, Tom, I love x265, I love your code. Can you just make it 10 times or 20 times faster without changing the resources? And I say, yeah, I hear you, we're working on it. So when we talk about efficiency, there's kind of 2 kinds of efficiency in the world of video encoding. One is that compression efficiency, and the other is the efficiency of running on a particular platform. How fast can it go to achieve a certain result? Of course, there are hardware encoders available. There are companies that make chips, ASICs, custom chips that just do nothing but video encoding, or FPGA-based encoders, which are sort of like hardware, right? Programmable hardware. And for a 4K channel, my understanding is that it might be 5K, 7K by the time you're all in per 4K channel. I think all things being equal, everyone in the world has told me we would prefer a pure software encoder. We'd prefer to have our operation virtualized. It can run in our data center, and the only thing in our data center is compute, a single commodity compute. I don't have a bunch of fixed function gear. I just have compute, and I can run anything I want on that compute. I can do anything at any time. I can analyze data. I can do machine learning. I can look for data tagging or what, and I could do video encoding as well. So it makes my operations and the gear that I buy much more flexible. It's constantly upgradable. There are many, many benefits to software, but we need to make it go faster. So the first thing we do is we're constantly looking at how can we get more quality for any given bit rate. We're always looking at how to just make fundamentally a better encoder, and we have a dedicated set of engineers and architects that work on that like full-time. Just how can we improve the actual compression efficiency? And then other side of it is just pure performance. How can we extract every last ounce of compute power out of any given processor or server? We have over 1,100 kernels. You get down to the low-level kernels, like taking an 8x8 block of pixels and calculating the sum of absolute differences, or the sum of absolute transform differences, or the mean squared error. We have 1,100 of these kernels because we have all these different block sizes and variations. We go and do hand-tuned assembly code optimization for them, right? We don't just trust a compiler. We have engineers look at actually the machine code and optimize that machine code to get every last ounce of performance. So x265, you will find, will bring your computer to its knees. It will not only max out the CPU, the temperature will go to max instantly, and it will beg for mercy. In fact, overclockers have found that they used to say, okay, I overclocked my system and it's at 5 gigahertz and it's stable and I ran all these synthetic benchmarks and it was great. And then I just tried to do some video encoding and it crashed. You got to fix your software, Tom. What's the matter? And I said, no, it's not my software. It's that when you really want to benchmark, you have to use this because it's going to extract more performance. We're looking at leveraging hardware encoders. We're looking at new architectures. So I mentioned, we have all these kernels. We get big, big improvements when we go do this work, right? It's a huge amount of work. It's many, many developer man-months, but it has to be done. I'm happy to tell you that the new Xeon processors that were just announced and just launched, we've been waiting for them for years, we're getting roughly 50% more performance per core, or more than 50% per core or thread than the older Broadwell or Haswell generation Xeons. So this is helpful to us, right? And then they have some pretty decent pricing and arrangements that allow you to get more cores per dollar. So we'll try to wrap up here. Another thing we try to do is parallelism. We try to parallelize as many processes as we can, but there's inherently a serial nature to video encoding where the block I'm trying to encode right now relates to the neighboring blocks or other frames, blocks and other frames I may want to make reference to. So there's only so much parallelism we can gain. We have found every bit of parallelism using every method. The methods Dan mentioned, wavefront parallel processing, slices. We haven't implemented tiles yet. There hasn't really been a call for it, but we do have slice parallelism. So, frame encoders call row encoders call CTU encoders as a structure that encodes CTUs one at a time, and that breaks down into further parallelism with CU encoders and so forth. And we get big benefits from that parallelism. So for adaptive bitrate streaming, you're going to encode one video to multiple quality tiers and then have an adaptive bitrate server that's going to talk to the client, and they're going to see how much video is in the queue of the player application, and if it's running dry, we'll switch to a lower quality tier to give you, a lower bandwidth version. We kind of recommend our CRF constant quality with VBV to kind of cap the peak bitrate, and that combination is known as cap VBR. You can produce all those different quality tiers and then let the streaming media server and client handle the negotiation of figuring out which quality tier to switch to. In x265, you can assign an x265 instance to a particular processor socket and to particular threads in that, so you can run multiple x265 instances in separate cores in a server. And we have, for ease of use, just like x264, we have 10 performance presets. They're from ultra fast to placebo mode. Placebo meaning if you enjoy the placebo effect, use that instead of very slow. But there's almost no benefit. It just runs a lot slower. So very slow is kind of the practical, slowest, highest quality setting we would recommend. But you see this, it's hard to put it on because it's almost exponential, but there's a big difference in speed. This is a basket of clips of different sizes, but a very big difference in speed range, but then there's this trade-off. So this is sort of the speed versus quality trade-offs that you can get, and you can just use those presets to find the place along that curve that seems to work for you. We have a lot of new algorithms we're always working on. We don't put them into the presets too often. Every 6 months or 12 months or so on, we go back and reanalyze all the presets and we put the new algorithms in there because we don't want to upset people who use it all the time and count on a consistent result. But you can go find the new options that you can add as you go along. And then for real-time encoding, the new benchmark is really 4K 10-bit encoding 60p. This is what I'm hearing broadcasters want, and sports is going to look fantastic. If you're going from 1080i 30, essentially, or 720p 60 to 4K 10-bit 60p, you're really going to see the detail and really going to see the action. But that's an enormous amount of computation. With the new generation of Xeons, we do have enough compute power to do that, and we have new algorithms and new configurations that we're working on. So I won't go into all the details, but we have a long and rich roadmap of many improvements. We do have a premium non-open source encoder library that runs on top of x264 and x265, and that can automatically run multiple instances of x264 or x265 to do things like parallelize jobs, produce multiple quality tiers. We have a lot of different features like a control system that automatically, dynamically changes quality to keep up with the FPS that you need, the frame rate you need, but also maximize quality so you don't have to use kind of fixed conservative settings so you won't drop frames. And with UHD Kit, you have these advanced features. ABR encoding we can do twice as efficiently as just doing each bitrate tier as separate instances. And for real-time encoding as well, we can further parallelize work, take advantage of all the cores and threads. Like today on the Xeons, you may have 112 threads on a server. 5 minutes? Okay, yeah, I'm done. So UHD Kit, we have a very aggressive roadmap, and things like cluster encoding, hardware acceleration, noise reduction, that sort of thing. And that's it. If you have any questions, come see me afterwards, or go visit our website, x265.org, or shoot me an email. Thanks very much.